Assignment 7-4. Let's do this. The first questions, this is all pre-calculus mostly on logarithms. Good review. You need it. We'll do it together. Look at each statement there. So I'm going to write it down. Number one, log A plus B is equal to log A plus log B. I'll just show you here. Is that a true statement or not? Is that a correct property? And the answer is no. The correct property is A times B equals that, not A plus B. This is false. No, 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 yes. The product leads to that, not adding and adding. Do you know your properties? Let's see again. Number two, ln A plus B is equal to ln A times ln B. No, no, no. That is false. I'm not even going to correct it. So there is no property when you're adding inside a logarithm. Number three, log A subtract log B is equal to log A divided by log B. Oh, this one's close, but still false. The correct answer to this is it would be log A divided by B. That one's correct. This one's wrong. They are not the same thing. So look carefully in terms of being able to write it as one logarithm. This is called the quotient property. That is incorrect. Number four, log A divided by B is equal to log A divided by log B. True or false? False. So, yes, I like this. A divided by is the quotient rule. This would be equal to log A subtract log B. That is the correct one. That is incorrect. Boom. Number five. Ln x cubed is equal to 3 ln x. This one's so close. A little tricky. This is false. That is not the property. The property is this, and you might think, oh, that means the same thing. And the answer is no. So those parentheses means the exponent is outside the logarithm, not inside the logarithm. That's true. That's false. Just look carefully. Number 6. Ln, I just did that one. So yes, number 6 is true. Number 7. Ln x squared equals 2 ln x for all of x. So close. This one, so close. Sometimes I have my family play Kahoot, and my little 3-year-old does it, and she doesn't have a clue, and she's just pressing any button, and she says, so close, in terms of getting the right answer on Kahoot. Anyways, ln x squared equals 2 ln x, so close. This is the part that's wrong. Logarithm has a domain restriction. So we cannot have a negative number or 0 inside a logarithm. So for all of x is false. So number 8 says the same thing, but then it has a domain restriction. It says for x is greater than 0. That part is true. So this is the correct one. This is the bad one. All right, that's 1 through 8. Just reminding yourself of properties of logarithms. Next page, number 9. Can you change something from logarithmic form to exponential form and vice versa? Let me just write these down, and then we'll do them. So number 9, number 10, number 11, give myself a little room, 12, these are all, I think, very basic pre-calculus kind of questions. 13, we'll see, doesn't mean you don't need to practice them. Getting there. I'm just writing these down so I have some space to work with, and I don't have to go back and forth and give myself a headache on this. All right, I'll stop there. Let's do these, and then we'll do the equations. So, can you write this as a logarithm? So a logarithm is another way to write an exponent. So the exponent is -3, and to write -3 as a logarithm, the base is 5, and what's inside is 1 over 125. Same thing for number 10. To write this as a logarithm, the exponent is x. We have a special logarithm with a base of e, that's ln, and then 17 goes inside of it. Number 11, can you write this exponentially? So that's an exponent right there. Can you write this exponentially? So it's inside the logarithm, 729. The base is 3, and the exponent is 6. Just practicing. Number 12, oh, can you simplify this? Right? See, I just wasted time there. 12, just write it as a exponential. So this is a common logarithm. The base you don't see is 10. So x is equal to 10 to the exponent, -2. Number 13, can you simplify this? E and ln undo each other. They're inverses of each other. So this answer is just 2x plus 1. Again, ln and e undo each other, and the answer is just a plus b. Know your properties. Number 15, notice we have a base and 5. They undo each other, and this answer is just root p. Here, same thing. 3 and the base of the logarithm is 3. The exponential and the logarithm undo each other, and the answer is just m squared. They cross each other out. Number 17, you have to solve an equation. So log 2, base 2 of x equals 3. Can you solve this equation? To solve it, we're going to write it as an exponential. So what's inside the logarithm, the base and the exponent, and then 2 cubed is 8, and you have your answer. Be careful for a logarithm. It has to be a positive answer when you plug it back in. So there could be what's called an extraneous solution here that we have to be careful about. Number 18. Number 18, we're solving the equation ln x equals -1. We could use a calculator on this one, but the exact answer we could do by hand. How do I solve this is to write it exponentially. So x is equal to e to the -1. That's it. Or you could write the answer as 1 over e, and you solved it. So know how to write it exponentially, know how to write it logarithmically, and practice. Number 19, x squared is subtract 1 is equal to log 3, or log 27 base 3. Here we go. Solve for x. So to solve this, on the right side, I'm going to simplify this to begin with. So this simplifies. When you evaluate a logarithm, you're finding the exponent that makes it true. The base is 3. What exponent gives you the answer 27? So 3 to the exponent 3 equals 27, and then you can solve it. So add 1, and for this one, the answer can be negative because we don't have a variable inside the logarithm. So it could be positive or -2. Number 20. Again, I want to solve for x here. So I'm going to write this exponentially. So the answer is 64. The base is x, and the exponent is 3. The answer there is +4, because 4 to the exponent 3 is 64. 21. In number 21, we have to do some graphing. So the first graph in 21, we're going to remember that graph and then kind of change that graph as we go along. So if I want to sketch this graph, I need to know 2 points in the asymptote. What might be helpful is to understand the inverse of a logarithm is an exponential. So that logarithm and this exponential are inverses. It might be easier for you to remember 2 points on the exponential and then inverse it back. So on y equals 2 to the x, if you plug in 0, the answer is 1. If you plug in 1, the answer is 2. And there's an asymptote at y equals 0. I then inverse those back so that on the logarithm, if you inverse it, these are the values you get when you inverse it back. This is what we're going to graph. So I'm going to start with 1, 0, 2, 1, and then we have an asymptote over 0. Now the curve of a logarithmic function is concave down. It goes forever down and forever up, but that's the curve of a logarithm. So we're going to remember that curve, and we're going to remember these points as we do the other questions. Number 22. So we have y equals log, the base is 2, and then x plus 3. And I want to graph that. So again, I'm going to start with what I just did, and I'm going to transform it. So I just used these points and this asymptote for this parent. And then this is almost the same logarithm, but everything has been shifted 3 to the left when it's inside the parentheses. This h is negative 3. It's 3 to the left. So if I go 3 to the left, these are the points that I'm going to use. So I'm going to go 3 to the left, and then I'm going to graph that. Okay. And then the curve. Let's try number 23. It's y equals a log, the base 2 of negative x. Again, I'm going to start with the points of the parent, which is the base with just x. I just wrote them down. 1, 0, 2, 1. X equals 0 is the asymptote. And I'm going to change it. And how these change is this only changes the x value. And I'm going to divide every x value by negative 1 to do this. So this becomes negative 1, 0, negative 2, 1. And then the asymptote, when you divide by negative 1, stays at 0. It creates a reflection over the y-axis. So what does that look like if it's a reflection over the y-axis? So we have negative 1, 0. We have negative 2 and 1. And we have the asymptote over 0. And then what does the curve look like when it's been reflected? And that's what the curve looked like, that you've reflected. On the right, you've reflected it over to the left. Number 24. 2 more graphs, right? Yeah. So what happens with the absolute value of this? So let's look at what that does. So when the bars are on the outside, it's a reflection. And this means that all the y values will be positive. So I have the graph of log x base 2, where I have the points 1, 0, and 2, 1. And this is what the curve looks like, right? And we have the asymptote at 0. But the part of the curve that would be negative, because of the absolute value bars, that's been reflected up. And all of those values now become positive. So this part that would be down this way, like this whole part here has been reflected up, and those values are now positive y values. Last one. I know what this one is. What happens when the bars are on the inside, like so? And so for this one, it's a little bit different. So the right side will stay exactly the same. So 1, 0, 2, 1. This picture here that we started with stays the same. But then what do the absolute value bars do? Is it makes all the x values positive. So that means you can plug in negative 1. You can plug in negative. So negative 1 becomes positive 1. So negative 1 gives you the same answer as positive 1. And negative 2 gives you the same answer as positive 2. So in other words, it's a reflection again. So when you put the bars on the inside, it actually creates 2 curves because of that. And the only value x cannot be here is 0. So negative numbers and positive numbers work now. And now we have 2 curves. And the only value that the domain restriction that can't be is 0. 26. It says, without using a calculator, find the inverse and graph them both together on the same graph. So let's do that together. So let's start with writing down the function. So f at x equals e to the 2x. We're going to find the inverse and we're going to graph them both. So to find the inverse, we're going to switch the x and the y around. So that's the inverse. And then to solve for y, we're going to write this as a logarithm. So 2y is equal to ln, that's the logarithm of the base of e of x. To get y by itself, divide by 2. So now the symbol there is there. That is the inverse. Then if you want to sketch them together, what it would look like, well, e to the 2x would look like this. That's what the exponential curve would look like, and then it gets reflected. And that's what the inverse would look like. So you have the function, the exponential, and the logarithmic curve, and they're reflected, and there's the inverse, and that's what the sketch would look like. Number 27. F at x equals ln x subtract 1. So I want to find the inverse. So I'm going to go x equals ln y minus 1. And then I want to solve for y. So I want to write it exponentially. So y minus 1 is equal to e to the x as an exponential. Add 1 to the other side, and that is now the inverse of this. So there's the inverse, there's the function. What would the sketch look like if you did this? So the first sketch, it's been shifted 1 to the right. So instead of 1, 0, it's 2, 0. At 1, there's an asymptote. So that's what the curve would look like. And then if you draw the line y equals x, it would be reflected on that. So instead of 2, 0, it's 0, 2. And then you have the graph. So here's the graph of the inverse, and here's the graph of the logarithm or function. This is f at x. This is the inverse f at x. All right, 28. Use properties to expand each logarithm. So ln a divided by bc. Let me just write them all down right away. 29 is ln x times y squared. 30 is ln a plus b squared over c. So can we expand it? And then we'll do the other direction. So do you know your properties of logarithm? So this is the quotient. So quotient means you subtract. Then I'm going to use parentheses. And then there's a product in the denominator. So that's using properties of logarithms. So it's ln a subtract ln b plus ln c. Here we have a product. So we're going to add. And then the power property, that exponent 2 is written in front of the logarithm. So do you know your properties to be able to expand a logarithm? Here we have a few things happening. So the exponent 2 gets written in front. Remember, a plus b can't be expanded. And then dividing means you subtract. So there's 3 basic properties to do with quotient, product, and power, and to know where they belong. Number 31. I'm just going to write them down. 32. 33. And then let's do it. All right. So for these, they are expanded. Can use properties to write it as one logarithm. So what am I looking for to write this as one logarithm? So if we're adding, it means we're multiplying. And the number in front becomes the exponent for y. So it's x times y squared. For this one, we're subtracting. That 3 becomes the exponent for x divided by, and then 1/2 becomes the exponent for y, and the exponent 1/2 means the square root. 33, to write this as one logarithm, we have a subtract. Now be careful here. This is actually, if you distribute to get rid of the parentheses, this actually becomes a plus. So you have a negative, and then a negative times a negative makes this plus, just to be a little trickier, right? So a is in the numerator. The 2 becomes the exponent, so b squared is in the denominator. And because this is positive, the c is also in the numerator. So only ones that are negative become in the denominator. 34. In 34 it says, without using a calculator, can you solve these equations? And then we're going to solve it with our calculator. So how would I solve this? Ln and e undo each other. So it's just t squared subtract t equals 6. Subtract 6, make it equal to 0. It's factorable. It's -3 and +2. If I solve it, each factor has a solution. For an exponential here in the exponent, there are no restrictions, so it's done. 35. We have e to the exponent 2t, subtract 1, and then subtract 3 equals 0. So to solve this one, to get e by itself, add 3. Then when the exponential is isolated, write this as a logarithm. So the exponent is 2t subtract 1. The logarithm with the base of e is ln, and then what goes inside it is 3. To get t by itself, you would add 1 and then divide everything by 2. Number 36. Solve this equation. I'm just writing it down real quick. So to solve this equation, first I'd use properties to write it as one logarithm. So when you're adding, it means you multiply them together. Next, after you multiply them together, we're going to write it exponentially. So it's inside the logarithm. The base and the exponent, 2 cubed, of course, is 8. This is now a quadratic equation, so we're going to make it equal to 0. So we're going to subtract 8. Then we're going to factor this. So it's +4 and -2. And then each factor is a solution. So the first factor gives you -4, and the second factor gives you +2. For this one, we have to be careful because there is an extraneous solution. So -4, if I go back and plug it in, that makes that logarithm a negative number inside, which is a restriction.
Hello, guys.
Hi, Juliana. Aw, I miss you too. So the only answer there is +2. The -4 is what we call extraneous. All right, 37. Oh, next page. Are we getting to an end here? Third page. Oh, I like these because I know how to use my calculator. 3 times e to the -x plus 1 is equal to 5 subtract x squared. They said, use a calculator. Well, I don't have to ask me twice. Let's use your calculator. So we're going to turn on our calculator. Press pause if you need to get your calculator. I'm going to clear what I have. All right, here. Here it is. Press menu, algebra, solve. So again, press pause if you're not ready. And then type in the equation. So I see 3e to the exponent -x plus 1. Move the cursor, equals 5 subtract x squared. And then I'm going to go comma x to solve for x. Be careful. This is the e you're using, right? That e. You're not using that e. No, that's the keyboard. That's the number, e. And then you have your two answers. So I'm just going to write it to 3 decimal places. So one is 0.552, And the other answer is 1.963. For number 38, again using our calculator, ln 0.5x is equal to 0.2 subtract e to the x. I'm going to use a calculator to solve that. Show you again. So how do we solve with our calculator? So we're going to go menu algebra, solve. We're going to type in ln. Now ln, ln, is right there in blue. So control that. There's ln 0.5x. Move the cursor equals 0.2. Subtract e to the x. Let me just make sure I did that right. Comma x. So there it is typed in. And then we get one answer, 0.483 or 2. You never have to round the final answer for an AP exam. 39. It says find the values of the logarithms using your calculator again. Again, I like using my calculator. This calculator, you do not need to change the base. Let me just write down the two questions. So you can just type it in. Just know that you know how to use your calculator to evaluate a logarithm. So the first one to evaluate, know where the logarithm button is. So that's where it is, right there in blue. So press Control and that button right there. That's what pops up. Type in the base and then the number and then Control Enter, and that's it. You don't have to do anything else. Super ridiculously easy. 2.726. Can you use your calculator to evaluate that logarithm? So I'm going to press log. The base is 5. Inside is 0.02. And there's your answer. So negative 2.430. All right, 41. In 41, it says use a first derivative number line to determine whether that function, x cubed, subtract 9x squared plus 27x, subtract 36, is it strictly monotonic? So does it only increase or only decrease? How can I show that with calculus? So to do that, we're going to do the first derivative. That's 3x squared minus 18x plus 27. We're going to make it equal to 0, and we're going to solve this by factoring. So I'm going to factor out a 3. So I'm going to divide everything by 3 to begin with. And then what's left over, I'm going to factor. So the two numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. So I'm going to write that as negative 3 squared. That's the derivative right there. X subtract 3 squared. So if I solve it, the answer is positive 3. But more importantly, so that's my critical number, that when you plug in a value smaller than 3, when you square it, the answer is positive, and the answer is positive. So no matter what number you put in, the answer will always be positive for the first derivative. That means this is strictly, f at x is strictly increasing. So that means it's monotonic. So the first derivative number line tells you whether it's only increasing, only decreasing, or does it have a turning point or more. 42. If f at x equals 2x to the 5th plus x cubed plus 1, and the inverse, the derivative of the inverse at 2, what does it equal? So let's see if we can do that. Oops. So you're given a function. You're asked to find the value of the derivative of the inverse at 2. How do I do this? So understanding the relationship between the function and the inverse is essential. That means the x and y have been switched. So this is the x coordinate of the inverse. So if I inverse it, it's now the y coordinate for the function. So what I need to do here is I need to take that 2 and it becomes the y value for f of x, and I have to solve this equation. Now I'm just going to solve it with my calculator because I can. So I'm going to solve this with my calculator to find what the x value is there. Oh, what did I type? I know I typed in something wrong. What did I type in wrong? 2x to the 5th plus x cubed. It's negative 2. Did you say that through the video? All right, let's do that. It's okay. It's negative 2. See, like one little mistake, right? I'm saying it's not irrational. I know it's not. So negative 2. You think, does that make a difference? Yes. So it should have been negative 2. Here, that's my mistake right there. So this is negative 2. So if I solve it, x is equal to negative 1. So let me just try to understand this for you. F at x, the point is negative 1 and negative 2. For the inverse, you inverse it. So it's negative 2, negative 1. I want to find the derivative here. So if I find the derivative at negative 1, I just do the reciprocal to find this. So that's my goal, right? Is to find this. So if I find it at negative 1, then I just do the reciprocal, right? To be able to find it. So let's use our calculator again. See if I can type it in right. So menu calculus, I want to find the, menu calculus, derivative at a point. So the variable is x, the value is at negative 1, first derivative, and then I just type in 2x to the 5th, move the cursor, plus x cubed, move the cursor, plus 1. So the answer there for the derivative is 13. So if that answer is 13, the reciprocal is the answer I'm looking for. So the answer here is 1 over 13. That's the answer right there. So I had to understand that relationship. That was the last lesson we did before logarithms. Let's do it again. Number 43. So in 43, f at x equals the square root of x subtract 4. And again, the inverse, the derivative, at positive 2. Maybe that's what I was looking at. It's kind of tricky. So we're doing the same steps. This x value is the y value over here. So make it equal to 2 and then solve for x. So I know the square root of 4. So x must equal 8, right? 8 take away 4, square root of 8, square root of 4 is 2. I can see it. It's 8. So that means that we have a point 8 and 2, or the inverse of that, which is 2 and 8. So what I need to do is find the derivative at 8 and then inverse it, or do the reciprocal. So I'll let the calculator do the good work. So I'm looking for the derivative. It's good practice too, using your calculator. The derivative at a point, x is the variable, the value is at 8, and then I'm going to type in the square root of x subtract 4, and I get 0.25, or maybe better if I just wrote it like that, 1/4, because I'm doing the reciprocal, right? So what's the reciprocal of 1/4? And the answer is 4. That's what I'm looking for. Done. So the derivative at 8 is equal to 1/4. The inverse of that this is what I'm looking for, is 4. So that's the relationship. Done. All right, 44. I think there's like 2 left. 3 left. All right. F at 4 equals 7. The derivative at 4 equals -3. And then it says use a tangent line approximation. That means use linearization to approximate the value of the function at 4 1/3. Okay. So if I'm going to use a linear tangent, if I'm going to use a tangent line to approximate, I remember that to write a tangent line, you need these 3 things. The x value is 4, the y value is 7, and the slope, the derivative at 4, is -3. Everything's given to you. So the tangent line is -3, x subtract 4 plus 7, right? That's the tangent line using those numbers. And then you plug in 4 1/3 into that tangent line to give you an approximate value. So 4 1/3 take away 4 is 1/3. -3 times 1/3 is -1. And then -1 plus 7. The approximate value at 4 1/3 is 6. All right, we're getting there. 2 more. 45 and 46. At 45, we have a conical tank shown at the right. Has a hole in the bottom. It's leaking 1 cubic foot per minute. So that means the volume is leaking at a rate of -1 cubic foot per minute. Find the rate of change in the height of h. So find dh by dt. That's what I'm looking for. When the height is 4 feet, and that tells you the volume of a cone that we need to use. So one thing I need to know is that the volume of a cone has 2 variables. I need a secondary equation that represents radius and height. Notice in this cone that the diameter and the height are an equal number. That relationship is the same no matter how high how much water is in there. That relationship between diameter and height is going to be consistent all the way through. So I'm going to write that down, that height and diameter are the same, and that ratio won't change. But I need a relationship between the radius. Well, the radius is half the diameter, or twice the diameter is twice the radius. So if I want r by itself, I need to divide it by 2 to get r by itself. That relationship I need in here. So radius becomes h over 2. And now I have one variable on the right side and one variable on the left side. So let me do a little bit of algebra. So this is 1/3 pi. If I square this, I get a 4 in the denominator. So 3 times 4 is pi over 12. And then h squared times h is h cubed. Now I can take the derivative with respect to time. This is a related rate question. 3 times pi over 12 is pi over 4. And then we need the hook on dh by dt. So there's the derivative. Now I can plug in some values. So dv by dt we said was -1. The height is 4 feet. And then this is what I'm looking for. So now I just have to solve for dh by dt, and it is over. So 16 divided by 4 is 4. So this is just 4 pi. So divide by 4 pi, and there's your answer. And make sure you have that in the correct unit, which would be feet per minute. So at what rate is the height changing as it's leaking? And it's changing at that rate, feet per minute. That's your dh by dt. All right, we are so there. Number 46, this is the last one. Thank goodness. So use the graph of the function to the right. And we're going to find the first and second derivative off of it. So for number 46, if I look at that graph to the right, I'm going to do a first derivative number line. So that is the first derivative. So first of all, I recognize it goes from -2 to 4. So I'm going to do that. And I also recognize that this entire graph is positive. So that means the entire graph is increasing. Next, I'm going to do a second derivative. And again, it's going to go from -2 to 4. And what do I notice for the second derivative is I have to take the derivative of this, which is the slope. So what's the slope between -2 and 0? That slope is 1. Between 0 and 2, that slope is 0. And between 2 and 4, it's -1. All right, that's all I need. So there's the information I'm going to use, and I'm going to graph. So let's start with the second derivative, or maybe the first derivative, or the function. Here, let's graph the function. We'll graph both. So what would f of x look like? So it goes from -2 to 6, to 4. And the entire function is increasing. But the second derivative, we have a positive number. So it's first going to be concave up to have no concavity. 0 means no concavity. The next part is going to be a line. So a line has no concavity. And then the second part is going to be concave down. And there's a possible graph of the function. Concave up, no concavity, concave down, and the entire thing is increasing from -2 to 4. What would it look like for the second derivative? All we're looking at is here. So from -2 to 0, the answer is +1. From 0 to 2, it's 0. And from 2 to 4, the answer is 1, -1. So we have a slope of 1, a slope of 0, and a slope of -1. There's the graph of the second derivative, a possible graph of the function, and the question gave you the graph of the first derivative. Mr. G Math over and out. I'm proud of you. There's a lot of questions, and you did it. And keep working, and it's going to get better and better. All right, Mr. G Math over and out. I'm proud. Till next time.